All right. It says we are identifying and applying Isosceles right triangle theorem. It's no shave November, so grow a beard no matter who you are. And we started our warm up already, finally. Okay, don't forget to check your grades on Skyward, and we are answering what is the range of values. On number one, what we did was we put x in the middle, less than, we subtracted on the left, and we added on the right. Same thing with number two, x in the middle, less than, subtracted on the left, added on the right. Let's do one more, x goes in the middle, right? You put less than, 19 minus 4 is what? 15. On the right side, 19 plus 4, 23. Okay. So, everyone with me. So that's how you do these triangle inequalities. Okay. All right. So we're on the notes called side. What is it called? Side angle triangle inequality. Okay. Okay. So I'm looking up here. Let's do this together. Stay on track. We can get this over with faster, so you can do what you need to do after that. Okay. So. All right, first things first, it says put the angles in order, okay? The angles in order from greatest to least. So looking at these three angles, which angle measurement is the biggest angle? Everyone agrees, 74 is the biggest angle, okay? But what's the name of it? So look at the capital letter in that corner, what is it? Angle B. Let's go ahead and write that down. Angle B for that first blank. We're doing greatest to least. Angle B is the greatest angle. Okay, now what's the middle angle? The middle value. Okay, 58 degrees is the middle number value of angles, which is angle A. Okay, do you see how when I name an angle, I put an angle sign? Great. Now, third one, the smallest angle is what? 48 degrees is angle C, okay? Because we know 74 is bigger than 58, is bigger than 48. That's the order, okay? Now, this next part, we're going to name sides from greatest to least. Which side length is the greatest side length? So, again, length being the number. Which side length number value is greatest? 18. Now, how do you name that side? I know there's like little lowercase letters. But when you name a side, you got to tell me the endpoint, the two endpoints on that entire side. So if I'm looking at 18, 18 goes from here to here. What are the two side lengths for that? Okay, AC. Now I know he knows. I need more people help me out here. Okay, right? So A to C gives me 18. So you're going to put AC, capital letters, and put in a segment on top of it. Looks like this. Okay, AC, that is the segment. Cool. Okay, now the middle side length is what? The middle one. 15, okay? Now, what is the name of the side with 15? What to what? B to C, right? Or CB works as well, either way. But I'm going to put BC with a segment on top. Okay? Last but not least, the smallest side is what? The 13, which is what to what? A to B, okay? Now, I want you to think. I'll be impressed, now in a good way, okay? Y'all can tell me, what do you notice about the relationship between the greatest angle and the greatest side? So I want you to think about it. Look at the greatest angle, look at the greatest side. What's the relationship? What? BC? AC. So I'm not asking for a value, I'm asking what's the relationship? Meaning, so like think about where they're located. Is there a relationship between where they're located? They're on the same what? Line? Well, okay, so B is the biggest angle here. AC is the biggest side here. So they're not touching, but so let's look at it. B is here, AC is here, right? A is here, BC is here, and then C is here, AB is over here. Is there a relationship that you see? Okay, let's draw some arrows. Okay, angle B is right here, right? Where is the longest side compared to that angle? If I were to draw an arrow, it would be like this, right? AC is the biggest side, it's over here. What words would you use to describe that? Okay. Everyone look right here. Look. Okay, your head's down. Everyone's eyes over here. Okay. All I need are some words. A very key word. Anyone can answer. Okay. Here's my biggest angle. Here's my biggest side. What's the relationship between them? What do you think? What does that mean? Even a guess would be like, cool. What do you think? No, I'm asking, what does this mean? The biggest angle's here, and the biggest side is here. Are they, what's the word you would describe? Not congruent, but I appreciate the attempt. Undetermined. All right, so one word that says what this means. When you are across a room, you are what? It's okay to guess and be wrong, but the silence is killing me. But I can wait it out. I'll win this one. Say what? Separate? They are separate. Okay. Here's an example. I'm the big angle. Over there is the big side. What do I do to get to that side? I do what? I walk. What? Across the room. Oh my goodness gracious. Okay, so it's across. Okay, it's not next to, it's across. Thank you so much. This has been a great learning experience. Everybody, the biggest angle is across from the biggest side. Okay? The middle angle is across from the middle side. The smallest angle is across from the smallest side. That's it. Okay? It's very simple, but I know some of us are just like Halloween leftovers in our brains. All right, so what do you notice? I want you to write down what we just said, and here's how I would put it in red. You can write this down too. Write this down. Okay. All right, so here's my arrow. The long side is across from the largest angle. Write that down, please. The same applies to the middle and the smallest. Okay. The long side is across from the largest angle. The same applies to the middle and the smallest. while you're writing, go ahead and write at the bottom this one too. The Isosceles Theorem. Okay. If you have two congruent sides, they are across from the two congruent angles. And vice versa means it works backwards too. Okay. So everyone, make sure you're writing this one and this one. Make sure you write both red things on the somewhere. Okay. At the very bottom of the page, you can write that one down too. So the bottom one goes for that bottom half, which we're going to talk about. So, I mean, anywhere on the bottom, it's fine. All right. So let's talk about the application of that isosceles theorem. So the isosceles theorem at the bottom says two congruent sides are across from two congruent angles and vice versa. Let me show you. We already talked about equilateral. Hey, look up here. Everybody. Heads up. Heads up, please. Please don't make me get up. Goodness gracious. We already talked about equilateral triangles. All the angles are the same. So this one's kind of obvious, maybe. Okay, if all the sides are the same, then all the angles are the same. So check it out. If you have a tick mark and across from that is 60, then across from this tick mark is also going to be what? 60. Okay. Does everyone see that? Equal sides give you equal angles. Equal angles give you equal sides. Okay. So let's do this on the next one. Okay. So does everyone see this tick mark? Follow with me. Across from this tick mark is 69 degrees. What do you think is going to be across from this tick mark? 69 degrees, the exact same thing, because if you have matching sides, they give you matching angles, okay? So let's write that down. Now, here's the problem. That's not the answer for x. Does everyone see there's an x at the top? What do the three angles in a triangle always add up to? 180, right? So now that I know both the base angles are 69, I can use that to figure out x. Now you can need, some of y'all know, you add them up, subtract from 180, you're done. I like to set it up algebraically. I'm going to add them up equal to 180, right? So angle plus that new angle we just figured out equals 180. You could insolve it, but I like to show my work. I'm going to combine like terms. 69 plus 69 is 138, I believe. And then my last step is to subtract the loner. Minus 138 gives me 42. So x up here is equal to 42 degrees. Okay. Does everyone see how that works? Equal sides, equal angles. Use that to solve for x, okay? Number two, it works backwards. This is the converse of the isosceles theorem, okay? If I have equal angles, what do I know about the sides that are across from it? Are those going to be equal? What do you think? Yes, two equal angles means two equal sides. So if this angle is 6, across from it is 6, across from this angle is also going to be 6. Okay, with me? Hey, pay attention. Okay, next one, last one on this page. All right, again, two equal sides. I've said it 2 or 3 times now. The two equal sides go across to make two equal angles, okay? So across from this tick mark is 75. What's going to be across from this tick mark? More people. Hey, if this across from this angle is 75, across from this side, what's going to be across from this side? What do you think? Okay, everyone needs to know this. I hope you all are listening and not writing this down. Please pay attention. Okay. So 75 is across from both sides. Now here's something weird. Do you see how this says 2? That is not 2 degrees. Look up here. What does angle 2 equal? 4x plus 14, okay? So that's going to be your third angle, and we need to figure out x, okay? So you need to understand this problem because you're going to see it on your assignment tomorrow and on the back of the note sheet here, okay? But I'm going to set up these 3 angles adding up to 180. So write small. Here we go. 75 plus 75 plus angle 2 is 4x plus 14 equals 180. Okay. Then I combine like terms. 75, I'm going to bring down 4x actually. I'm going to combine 75 plus 75 plus 14. All of those constant numbers add together and give me 164 equals 180. And then to get rid of 164, I subtract it. 4x equals 16. And then we divide to get x equals 4. Okay. You got to kind of write small because of that. Okay. Now we're going to do some examples, samples, problems on the back if you want to flip that over. All right, so on the back, okay, number 1, look at number 1 on the back, okay? Okay, number 1 on the back. It says, order the what? Sides. If you remember the front side of these notes, sides have 2 letters with a segment on top, okay? Now, I want you to notice, none of these sides are labeled. There's no number on the outside of any of these sides. So we have to use what we learned before. It's across from the angle, okay? So I'm doing it from shortest to longest. Go ahead and circle that. You always need to read this carefully. It's not always shortest to longest. Sometimes it's longest to shortest, right? So, very important. So what we're going to do is we're going to find the smallest angle and see what's across from it. So what is the smallest angle? 30. So you're going to go across. The whole notes from today are talking about across, okay? So across from 30 is what? What side? Okay. Across from 30 is what? It's not a number, it's a side. What's the side called? It's a cross, not right next to it. Okay, so check it out. Here's 30. Across from the smallest angle is this side. What is this side called? What are the 2 endpoints? FG, with a segment on top. Okay. Now, what's the middle side? Middle angle? The faster we do this, the sooner y'all can do what you need to do. What's the middle angle? 32. What's across from 32? This side over here. GE, right? So you want to go across, split down the middle, get GE. And now the biggest angle is 118. What's across from 118? EF or FE, it's fine either way, okay? Do you see how we have to go across from what we know to figure out what is missing, okay? Let's do that again, but this time we're going to do it with angles, okay? We're doing the smallest to the largest angle, okay? But we don't have any angles labeled. Do you see how there's nothing on the inside here? So what we need to do is look at the sides. Which side is the smallest side? 7. Look up here. From 7, you go across. What angle is that? Angle R. Okay. What's the middle side length? 9. What's across from 9? Angle T. Angle sine T. And then the biggest side, 12, across from that is angle S. Okay. Okay. And then number 3 is like number 1. The sides, what's the shortest to longest? What's the smallest angle? What's across from the smallest angle? UW or WU, either way. What's the middle angle? What's across from that? VW. And then the biggest angle, what's across from that? VU. Okay. Do you see how you're writing stuff across? You're looking for the sides, they only give you the angles. You got to look across. If they give you the angles, you got to look across to get the sides, okay? I want you to try 4, 5, and 6, okay? And see what you get. And we'll go over in just a minute. Don't put these up, don't turn them in. Just do 4, 5, and 6, and we'll talk about it in a minute. Number 4 was like on the front side, if it's equilateral, and across from this one's 60, then across from this one is 60. Number 5, equal angles give you equal sides. If that one's 12, then that one is also 12. And then on number 6, we went over one like this. If across from this tick mark is 46, then across from this tick mark is also 46. And then angle 2 is going to be this, right? So it's 46 plus 46 plus 11x plus 11 equals always 180. Combine like terms, you get 103. So 11x plus 103 equals 180. You get rid of the loner, and then you divide. You should get